Welcome! In this video, we'll explore the topic of determining the sample size in confidence intervals. If you are not familiar or need a refresher with confidence intervals, please click the pop-up to watch my video called Confidence Intervals for the Mean first. The sample size is the number of participants or observations included in a study, usually denoted by a lowercase of n. If you use a capital N, then that is the size of a population. What is the appropriate sample size for a survey? Of course, larger samples are generally better. However, let's find out the minimum sample size for it to be valid in this video. Here are the formulas to construct a confidence interval, where E stands for the margin of error, which is a range of values below and above the sample average. The width of a confidence interval is a function of the confidence level, the standard deviation, and the sample size. The first function is the critical value, which is associated with the confidence level. Again, if you need a refresher on finding this critical value, please watch a separate video called Z Critical Values in Confidence Intervals. The second function is the population standard deviation, and the last one is the sample size. We'll focus on this sample size in this video. As a practice, let's calculate the margin of errors with a fixed confidence level and standard deviation by changing sample sizes. First of all, we need to find the critical value associated with 95% confidence level. Here's a table showing 4 common confidence levels and their critical values. The 95% centered area corresponds to the 1.96 Z-score value. So we use 1.96 as Z-critical value. If the sample size is 20, we substitute each function value into the formula to get the margin of error as 1.05. Then how about n equals 30? Change n position to 30 to get the margin of error 0.86. When we increase the value of n to 40, we get 0.74. As we can see, if we increase the sample size, the margin of error values decreases. This is because the sample size is on the denominator. If you divide some value by a larger number, the result becomes smaller. Here is the sample size formula we are going to use. In order to have the desired confidence intervals, we can decide the sample size. This n value must be the whole number because it is a number of items or people. So the fractional part must be rounded to 1 as well. Therefore, please round the calculated answer up to the next larger integer. For example, if n equals 25.0325 and so on, the fractional part must be counted as 1. So the sample size should be 26 in this case. As soon as you read how many, understand this as finding n. This means the question is asking for sample size. Let's pull out the formula. The first function is the Z critical value. Substitute the critical value which is associated with 98% confidence level. Let's take a look at the table again, or you can use a Z table to find out the value. 98% confidence level corresponds to 2.33 Z-score. So we use 2.33 as a critical value. As for the standard deviation, it is given as 14. For the denominator, margin of error, the keyword from the question text, within, indicated as. Then we substitute each value into the proper position. Multiply 2.33 by 14 and divide it by 2.5 to get 13.048. Then do not forget to take a square after calculating the inside of the bracket. The answer is 170.2503, and so on. Next, round the answer up to the next larger integer to get 171. Therefore, the sample size of 171 smokers is needed to have the margin of error 2.5 in this confidence interval. Please comment if you have any questions or topics that you'd like to see. Thank you for watching. See you again.